Excellent. Well, if you are now tuning in, this is the Retrotec webinar with Nate Adams. We're doing a case study on an envelope and HVAC retrofit that he worked on with a little bit. And we also have Peter, the homeowner, that's on with us too, to give his perspective of how that project went. So we'll go ahead and do some brief introductions here. For those of you that are new to our webinar series, my name is Sam Myers. I serve as a building science consultant for Retrotec. We manufacture air tightness tools such as blower doors and duct testers and high precision manometers, things such as that. And in my former life before I was here, I was a building scientist for an energy research firm called Advanced Energy in Raleigh, North Carolina, where I did all kinds of testing and consulting for contractors in the Triangle area in C. And of course, with us today, once again, is Mr. Nate Adams. Nate has his hand in quite a few things. He's heading up a new initiative called HVAC 2.0, which is kind of picking the cream of the crop of the HVAC industry for residential to show how they can incorporate more envelope-style consulting into their work to make houses more comfortable and efficient, better air quality, and all that good stuff. And he also has his own company where he works with customers like Peter here called Energy Smart Home Performance in Ohio. So this project is going to be based on some work that company did. And if you've ever heard of Nate the House Whisperer, well, this is him here. Hopefully he won't be whispering to us today. We'll be able to hear him clearly. So that's a great website for both contractors and homeowners to go to learn more about how to make their homes more energy efficient, comfortable, better air quality, and all that. So he has a lot of published works with Green Tech Media, JLC, and of course, last but not least, he is the author of the Home Comfort book, which in our opinion is the perfect starting point when you get into this kind of material, especially from a new contractor or a homeowner standpoint. To really see how all aspects of a house tie together and work together as one system. So Nate, thanks for joining us again today.
It's my pleasure. Thanks for having me.
Sure.
And most importantly, thank you to Peter.
Yeah.
You want to flip over to my slides and I'll introduce Peter.
Absolutely. So let me back out of here. If you go to present.
And then we'll test if I can control your screen still. It says I can, but can I?
There we go. You should have control.
Well, we'll find out in 1 second. So I'm really happy to have Peter on here. Peter's going to be giving me a hard time at some point here. I pretty much guarantee it. We've given each other a hard time through this whole project. So he's got a very good sense of humor. He's very detail oriented on a bunch of things like related to engineering, and yet you might not expect an engineer to consistently jump out of perfectly good airplanes. But how many jumps do you have now, Peter?
Oh, about 6,600 or so.
Oh, wow.
There you go. It's one or two.
Yeah.
So, but this was kind of an interesting risk that we came together on because we first met. It was the end of 2015. You believe it's been like 4.5 years, Peter?
I know. I just looked at that too. It's like time flies.
It has been a long time. All right, let's see if it will let me click. Come on, honey. There we go. So that in the promo photo, that's actually Peter. So where is that, Peter?
That would be Baffin Island. That's in the Arctic Circle, like up near Greenland.
Nice.
Wow.
I presume that's a wingsuit?
That would be a wingsuit, yes.
Right. You are cooler than me.
Really gets the adrenaline going.
It does. And here he is again. This is actually with my wife. She jumped with him like 3 years ago. And Peter, I'm going to say it right here publicly. I'm jumping out of a plane with you at some point here. So once we're allowed to do that again.
I'm ready.
Okay. We'll figure it out. That's I'll be 6,600 and something or other. But that was pretty fun. And another thing, if you notice that his accent sounds a little bit different, he's from Austria.
Österreich, that's right.
I did speak German once upon a time, not quite as well anymore. But that sign cracked me up in your garage. And
Still there. My wife always parks in front of it, and she's not master.
Go Megan. It's awesome. So here's Peter at the end of the job. He's got an interesting background, and it really kind of you've been such a pleasure to work with through this, Peter.
Thanks.
So you had to be at least reasonable if I was going to invite you on a webinar. I still don't know what's going to come out of your mouth, so we're going to find out. Anyway, so I wanted to give some structure to this. So we're largely going to be going through a bunch of photos and things, we just wanted to lay out the arc of the project. And this is the standard arc that we use. It's now become the HVAC 2.0 process. But what we're going to go through, we're going to talk about the comfort consult, which is the first step where we figure out, like you see the Venn diagram to the right, what are the goals, what are the needs of the house, and what's the budget. Then we'll talk about the comprehensive planning process, which is defining what the project actually looks like, because Peter's house was not a simple project. We combined 2 HVAC systems into one. We redid the duct system to the upstairs system, and then we air sealed and insulated the entire house. So there was a lot going on this project. It wasn't super simple. So we do this comprehensive planning process. Some people might think of it as an energy audit that's advanced. So we'll talk about that a little bit, and then we'll dig into the project and what it looked like. And then at the end, we'll talk about the optimization that we've been playing with here for the last month or two. So that's what to expect. Okay, and I wanted to just touch briefly. So this is the same process that you saw before, but this is our diagram of it. And if you're working with an HVAC contractor that's using this process, they're going to have different forks than what Peter and I did. Because what Peter and I did, we did this line right here. So normally you're going to come into the process and you can get either a free quote from an HVAC contractor, or you can get a comfort consult. And then after the comfort consult, a lot of houses aren't that messed up. So if you just replace the HVAC with the right piece of equipment, right size, multiple stage, or what we like to call badass HVAC, that's the A+ path. And we did not do that for Peter because we had a lot of stuff to do on his house. It wasn't a simple project. And then you can see comprehensive planning process. And we put controlled comfort on the bottom there. This will probably shift, but just so that you have an idea of what the forks are. And this is a funny thing. So we do precision guesswork based on unreliable data provided by those of questionable knowledge. And the ironic thing is I should really be wearing this shirt. But the truth of the matter is everyone in the HVAC and insulation industries really should be wearing this shirt, because we're doing our best with imperfect information. But if we do this right and we employ a bunch of feedback loops, we can use this mediocre information to consistently get really good results. But you have to put a certain process around it to make that happen. So you're going to see us go through one today. So let's talk about the comfort consult. And Peter, well, next slide, I'll ask you a couple of questions. So here's what's involved in those. We do an extensive interview. They take like an hour to ask the questions. We do a blower door test and zonal testing. So we do some leakage diagnostics. And then we discuss what the goals are, what the problems are, and we begin to develop that budget. So what we're playing with is trying to see, can we get these 3 circles to cross because of viable projects in the middle? And then when we're done, we email a recap and let people know what the next steps are. But let's dig into this project now that we've looked at the overview. So Peter, you've kind of flipped through these. Did I get the goals right there?
Yeah, I think so. I mean, basically, I had contacted you because the upstairs furnace was stone old, it broke, and eventually I'm like, oh, I got to do something with it. And I didn't like having 2 systems, and I didn't like the way how they worked. So through some digging, I guess I stumbled across you on the interwebs somewhere. And you came out and we had basically exactly what you just said. We had this talk about what's my house look like? What do I want out of it?
And we got there.
Yeah.
The funny thing that kind of cracked me up, what precipitated this project was not the furnace failing upstairs, because you grew up in a country house with a wood burner and cold bedrooms. Right. You didn't mind the cold bedroom. It was when the air conditioner died.
That was the trigger.
That's how this 3.5 years later started.
Yep.
So we found that the house was pretty leaky, and I'll show what that means in just a second here. It was a 3,300 blower door on about a 1,600 square foot house. Depends exactly how you do it. And then the budget did kind of crack me up. Peter, you were the only one I never got a firm budget out of. You're it. That's it. You were my failure. I tried. But, we still got there. But it kind of cracked me up.
Yeah, well, to me, that the results were more important than how much money is it going to cost me. I was willing to be flexible with that.
Yep. Well, and you were, so we figured it out in the end. Yeah, that was kind of a funny thing. So this is the scale that we use, leakage to square footage ratio. So it's how many cubic feet per minute at 50 pascals, which is what a blower door measures. That's the raw unit. Compared to how many square feet the house is, we find this is a really useful rough metric. So we've been in plenty of arguments over this versus ACH 50 and the like. But what we find is when you get a house to about 1:1, so you see the B minus there, the houses tend to start to work. So if you want to control them, you can actually do it. Oh, there, Sam, you're flipping through.
Sorry about that.
It's all good. Actually, just go back one. So here's where, we'll get back there. Back to that spectrum, please. Peter's house was basically at 2:1, so that's like a D. And the issue with the house with that much leakage is they're typically very difficult to control. So picture a boat that has a decent sized leak in the bottom of it. Sure, you can just add bilge pumps and kind of make it go away, but you're just waiting for one failure to cause a bunch of other failures. That house was leaky enough that it made sense to try and figure out how do we tighten it up. And there's the house. So it's kind of a standard split level. There's probably a lot of these across the country. There's a lot of them here. I'd say, 5 or 10% of the houses here are splits. So it's something that's pretty consistent that we find. And we'll get to it in a little bit, but these houses have a couple of unique weaknesses where the two sections come together. There's usually a big stack that comes from the basement all the way up to the roof line. And you have to figure out where that chase is and get it sealed. And there was a big one on this house over here. And then also the bump out here is problematic. So those are just really common issues. If you look at a split, it's like, so how bad are those problems? And so we'll just flip through a couple of infrared pictures here from inside the house. So this is one of the bathrooms. This is the master. And so you can see this vent, and infrared pictures, they're very intuitive. If it's a cold color, it's cold. If it's a warm color, it's warm. And this was done in cold weather, so blue is bad in this case. I love this. Peter, you're making comments. I love that. Because the
there's questions to
not the smartest.
It's true.
It's funny. My Amazon package was delivered. Good. So since this house has ductwork in the attic, which is pretty unusual in our area, this system was put in after the fact. It probably was radiant before. But you can see that it was pretty leaky around that duct there. And then the bath fan. And then right here, if you can see this line, this is called a drop soffit, where the ceiling is about a foot lower. Really common in bathrooms and houses 50s, 60s, and 70s. And this typically has some weird framing above it, and this is almost always cold.
So Nate, did you take this photo while the blower door was running?
Yes.
Okay. So I'm thinking a lot of that cold air on that AC register is probably from duct leakage as well, which is why it might be a lot more cold than the bath fan.
Yep, exactly. Yeah. So it could be pulling through the duct and then through. There's all kinds of stuff that could be going on there. It's the good news in this case was it was likely that we were going to remove the system. So I don't worry too much about something if it's likely to get removed. Speaking of other common things, so this is a whole house fan here. And the curse of these things now is because our dew points are on the rise, average dew points in the Cleveland area are up about 5 degrees since 1950. So at night, these used to be nice. Like I remember when I was a kid, you'd throw the windows open at 8 at night as the hot day was starting to cool off, and you could actually get some breeze through the house, and it would be good. The problem is it's staying so humid these days that when you do that, really all you do is suck moist air into the house and you don't cool it down that much. So these are no longer very useful, which is kind of sad because they were nice. You just open some windows, turn this on for 10 minutes, suck some cool evening air in, and you're good to go for sleeping. It doesn't work well. But also, as you can see, these things leak like sieves. So it's pretty ugly. And in this case, he's got an attic hatch right behind it as well. So that's what the leakage is back here. So pretty leaky spot. This is another drop soffit. This is in the kitchen above the kitchen sink. So this is a old school recessed light you can see here, and that's it over here. Those things tend to leak, and I don't think I took a good picture step back, but this whole area, the soffit was turning blue as well, which is common. The drop soffits almost always go cold. And then this is in the basement. So this is the top of the basement wall. And then you can see the joist here. Now this house is unusual. It was moved, right, Peter?
Yeah, so the house was built like a mile down the road from here, like a road over. And then they put a airport and another runway in, and they moved this house over to this new spot. So the foundation is fairly new compared to the house. But it also meant that the foundation was built and then the finished house was set on top of it.
Yeah. So this is unusual that normally this would be a rim joist out of wood. And typically I only see blocks in old school brick houses, 1910, 1920, that kind of era. So that was unusual. But still you can see that it's pretty leaky. So they're really dark blue around the corners here. That's air leaks getting sucked in from somewhere. So we wanted to seal that area up. But these are the sorts of things we find on the comfort consults. And then we also take a look at what the existing equipment is. So here's the propane water heater, which it's still running for a few more months, right?
Yeah, I'm starting to, I think I'm down to like maybe 10% propane in the tank or something like that. So either when I'm out or the weather turns, the tank's going to be gone and the hybrid system's going to go in.
There you go. So he's got a heat pump water heater sitting in the basement, just waiting to drain the propane tank with this thing. So we'll come back to that in a little bit. And then here's the old furnace. So this was a downstairs furnace, which ironically ended up heating the whole house because the upstairs furnace was dead. And another important point, because this was an electrification project, if you have propane or fuel oil, the odds are very high that operating a heat pump costs a lot less. And Peter, you were tired of just trying to figure out the propane pricing all the time, right?
Well, there's a couple things to it, right? I mean, propane prices you can somewhat manipulate by, like I have my own tank, so I could pick who supplies me. And you can, if you buy in the summer, if you pre-buy, you have some control over the price. But I mean, I've owned the house since 2000, and I've seen from 77 cents to a gallon to very close to $2. And I think there's people that are, if you don't pre-buy or if you have to have it delivered just in the winter, you might end up paying way more than that.
Yeah, I've seen some people paying pushing $3. So yeah. That's a lot of money. The good news for Peter in this case is he already had a 200 amp panel, and that's typically more than adequate for doing one HVAC system and then a couple of electric cars. So you shouldn't need any more infrastructure than a 200 amp. So that's it for the comfort consult. I do want to pause. Are there any questions at the moment? Sam, we got anything we should cover?
Well, Zoom has decided to kick me out of the control panel.
Oh,
so
no.
you may need to go up and check.
Okay, I will go check. We got one BPI from Art Malarkey.
Yeah, so you do get one BPI CEU for this webinar. So just use the question box to input your name, your email, and your BPI number, and we'll upload that later on.
Cool. And Doug Kroll said 2 furnaces and 1,600 square feet. Why? Peter, any idea?
Yeah, and I kind of typed it up. I mean, in the end, basically what it was is there was no ducting or anything that connects the basement to the upstairs. So there was no way of getting the heat up, or they didn't think of any. And I think when the previous owner bought it, he wanted to have AC upstairs for sleeping, because when I bought the house, there was only a furnace downstairs, no AC. And there was an AC upstairs, but they really bought the cheapest piece of junk you can buy and installed it as cheaply and as horribly as you possibly can. So it never really worked well.
What do you mean? It had one return for the whole thing?
For example, yes.
That poor thing was starved for air. Well, so we'll dig into the comprehensive planning process next. Here, where'd my mouse go? Gotta love when that happens. There we are.
And we'll keep taking questions at the end of each section. So keep them coming. We'll get to you.
Yeah, exactly. All right, so here's what's involved in the comprehensive planning process. So we do a detailed inspection. So we're looking for root causes of the air leaks and the other problems that came up at the comfort consult. We measure the house and take a whole bunch of pictures. Basically, we're trying to wrap our head around it and create a 3D model in our heads of it. And then when I'm done with that, I go back to the office and I make a rough work scope. Like everything I can think of to do the house, I just want to puke it out into a spreadsheet and have all of that to work with in a little bit. Then we do packages. So we think about what's the best way to package things together with a bunch of different measures based on the budget. We actually start with kind of a crazy package that's everything we can think of, and then we back off to what we think is likely to work, and then we back off again to the budget. So that's what we're doing there, and then we go back to present the findings to the client. So just flip through a couple of things that I saw. Here's the bump out. I mentioned this earlier on. So lots of splits have bump outs to make the bedroom area a little bit bigger. You know, it sticks out 2 feet in the front. Sometimes it sticks out 2 feet in the back, and it does for Peter's house. So note the propane tank. You ready to get rid of that soon?
Very much so.
And there's 2 AC units back there as well. So that made life interesting. And then actually for air sealing details, the chimney right here made things a little bit interesting in the attic as well. It goes right through the soffit. Some other things, the living room has 10 of these little 4-inch retrofit recessed lights. And so here's a picture with the light on, and here's a picture with the light off. And you can see light shining through it. That's bad. That's air leakage. So these things were one of our prime things we needed to deal with. Also up in the attic, see all this kind of dark fiberglass here? When you see dark fiberglass, that's almost always a sign that it has been filtering dirt out of the air that's going through it. So that's an air leak usually, and it's coming from these wires coming through the top plate of the wall. Also, this is one of the ducts up in the attic, and you can see where the insulation, it might have been tacked on after the fact, but it definitely had ripped. So there was a lot of heat and cool being leaked out of this. So that needed to be dealt with. And then here's one of the drawings that I do so that we can build a model. You can do it any which way you want, but I keep trying things other than graph paper and coming back to graph paper. But I make notes of where are the supplies, where are the returns, in this case, where the HVAC in the attic is, the sizes of the rooms so that we can do room-to-room load calcs if we want to. So there's a lot of information collected here.
That's one of the many challenges of existing homes is no plans. So
Yep.
you're going to have to get creative and make your own.
It doesn't take that long, but that's a good hour and a half usually.
Yeah.
It's the biggest chunk, the biggest single chunk of my time at a house is just measuring it out.
Yeah.
And that also can help you figure out where there's a chase if need be, which we were looking for on this house so we could run ducts upstairs. And there wasn't a good place, as we'll get to. But another thing we do as part of the comprehensive planning process is we want to create blower door targets. So it's a combination of gut and measurement. But the house started at 3,300 CFM 50. And so we gave a very achievable target of 2,200 and then a tough target of 1,500. So running from experience. So generally, you can get 50% out of a lot of houses, but you're going to have to work pretty hard to get all the way to 50. You can get 20 or 30 pretty easily in most houses. So we wanted to see where that was. And by choosing those targets, it lets us do our load calcs. So load calcs are figuring out what size HVAC does the house needs. And mainly this leans on the leakage of the house and the insulation levels. Also set points matter. So we do ask what set points are. And as you'll see, Peter likes it a little bit on the icy side, which his wife doesn't agree with.
She may be wearing a hat right now.
So Megan is a saint for putting up with that, but that's okay. So anyway, we size equipment for the hottest and the coldest days of the year, but that's a problem because 98% of the year are milder than those way out there ones. And what we find is most furnaces in particular are 2 to 4 times the size that they need to be to heat a house. And that leads to temperatures like spiking up and down and up and down and up and down. And so houses get uncomfortable. So ideally, we size them tightly and they're multiple stage so they run all the time. And so here's what that ended up leading to. In doing the load calcs, we found out that where the house was, the load calc came in right on 36,000 BTUs, which to all of you HVAC guys, you're like, hey, look, 3 tons. We very consistently find when we true a load calc to usage and blower door, most houses here in Cleveland under 2,000 square feet come in right in the 3-ton ballpark, give or take 10,000. So that's where the house started. And then we ran, other way, we ran another load calc, assuming better insulation in this case, and then also tightening the house down to 2,200. And that got us to 30,000 BTUs, so 2.5 tons. And then if we tightened it more, and this was really just tightening, it wasn't much extra on the insulation side, we got down to just over 2 tons. So that might surprise people that here we have an existing 1960s split level house in Cleveland, Ohio, that a 2-ton could serve if it needed to. You need a little resistance backup, but you can do it. But the smallest furnace out there is 40,000. So you would have to use the smallest furnace for it to actually be sized right. And what the house currently had at that time was it actually had 2 70,000 BTU furnaces, but only one of them was functioning. But just that one was about twice as big as it needed to be. And to make that match the leakage of the house, so if we had to increase the leakage of the house, we'd have to basically triple the leakage. And it would be the equivalent of leaving a couple of windows open 6 inches all year long. That's what it would take for that equipment to be right sized. So that's what we say when we say that furnaces are routinely twice as large as they need to be. There's an example, and this is really consistent. Then let's just take a step back. So in what we do, we're trying to figure out what does it take to have high likelihood of solving problems. And so this is really how we think about things. We think of everything on a sigmoid, this S curve. And until you get to the top of the curve, and so this is odds on this side, and on the bottom it's work that you do or money that you spend, so it's doing stuff. Until you get up to where it's starting to flatten out, your odds aren't that good. And this was an interesting discussion because we were talking, Peter and I, about potentially splitting this project in 2 and doing part of it last year and then another part this year. depending on where the bids came back. And the curse of that was we would be down in this range by doing part of the project up front without doing all of the air sealing and insulation, where because we did all of it, we kind of got up here and you're done. Because your house is markedly better, right, Peter?
Oh, yeah.
And to kind of put the numbers on it. So remember the two targets. We had 2,200 CFM 50 for one target. That was pretty good. Like, I think that would be okay. We'd be the 80% odds of solving everything. But ideally, we want to get a little bit higher. So the 1,500 target gets us to where we're unlikely to fail, if nothing else. And all of this, remember, is theoretical and based on a combination of gut and metrics. Because you can't gather all of the information that you would like. I mean, we could spend days auditing a house and collecting a whole bunch of data points, but still not make it that much easier to predict. And in building the packages that we do for the planning process, package 1 is a budget package. Package 2 is, okay, this is what we think needs to happen to have good odds. And package 3 is, let's throw everything against the wall. And maybe you want to do some of it, maybe you don't, but at least you know what the options are. And you ended up kind of going in between 2 and 3, Peter.
Yeah, we sort of did. I think there was a stake involved. I'm not sure.
Well, getting to the 1,500, although I still missed as we get to. So there were a couple of minor failures on this project, and getting to the tougher target, because the official target was 2,200 through the thing, but I don't give up easily on blower doors. So keeps life interesting. All right. Are there any other questions we should deal with thus far? Looks like we're good so far. So now we'll dive into the project. So here's the fun part. So the first part is just kind of explanatory. So we have to do final scope and bids. Then we did the insulation preparation and actually a little bit of the insulation. Then we did HVAC. Then we did all of the insulation and air sealing, and then we optimized the project. So final scope and bids, we sit down and go over what all of the options are and what do you do, what do you not want to do. And then all the stuff that we come up with that you want to do. So Peter, you remember this conversation well, I'm sure. We discuss all of them, and then it's in a spreadsheet, so we add them all up, and usually we both fall over at the total and then go back and be like, so what can we slice? Or oftentimes what we'll do is we'll ask for bids on more work than we're really intending to do, and then possibly it will work out to where the numbers come in stronger. And you got lucky, actually. Both bids came in under budget, enough so that we got to do the whole thing. So that didn't suck. And so then it was time to jump off a cliff, proverbially.
Bring a parachute, just saying.
If I'm involved, make sure you have a parachute. How risky did this feel to you, Peter, by the time we got there?
This here, will I see the picture or the house?
The house. Well, let's do both. So what about this one? I'm kind of curious how you felt right at that moment.
This one here, at this point in time, you're pretty calm because there's nothing you can do about it anymore anyway. In the position where the guy is standing there, you might have some nerves. And if anybody cares, if you look at, so this is a fjord, there's a frozen fjord up in the Arctic, right? And if you look kind of across from where my head is, there's like a little valley back there. Mm-hmm. We camped there for 10 days in temperatures down to like -40 or so. So I think the 68 in the house is just fine. So, but about the house and the house project, I know you never got a budget for me for a fairly simple reason. I'm still maybe raised a little different or a little bit more old school. I like to have some money in the bank, and it was a judgment call, a gauge of like, how much of that money do I want to see go away for this project? And where's my threshold where I say, because I didn't want to have any extra loans or equity lines or anything like that. I just, this had to be viable to just go do it. Yep.
Write a check, move on. And you're probably about a third of our clients are like that. So we are always curious, where's the money source? Because sometimes there's a really hard upper limit, And sometimes if we go over budget by a couple grand, it's not the end of the world if there's, something that really should get done. Because just like on your project, we discovered a few things that should get dealt with that we didn't originally plan for.
Right.
Yeah, Nate, one thing that I hear you talk about a lot is going back to that initial pain point of what the client is feeling. And so as far as the budget goes, it's like, okay, well, you called me because this room was cold, or this room isn't feeling the way you want it to. In order to make that pain go away, these are the options that you can do. So that kind of sounds like what happened here. Even though there wasn't really an initial budget, there's still a pain point that Peter wanted to go away. So you still kind of have to figure out what that's going to cost to make that disappear.
Yeah, like in my case specifically, it was basically when you're sitting on the couch watching TV in the winter, you have the cold air coming down the staircase and hitting you on your back. And so that was really this sucks. Let's do something about this point.
Enough to make you want to jump off a cliff. Yeah.
That's right.
With the parachute.
That doesn't take much to make me do that.
That's a pretty low bar. If he's got a parachute in the car, he's probably going. That's funny. Well, that's good to just kind of hear that you weren't super nervous by the time we got going. All right, here's what the project really looked like. So we had to start by taking out the HVAC in the attic, including it was really crappy flex duct. And then getting the insulation out of there as well. Then we had to air seal the top attic before we put the new ducts in, because once the ducts are in, you really can't get to a whole lot of stuff anymore. Put the ducts in, put the HVAC in, and then air seal and insulate. So we'll run through some photos. Here's kind of the fun part, because we're actually getting into the work. So in pulling the unit out, I think this filter was just taped in there and had been in there since the system was installed, and nobody even knew that it was there.
Wow.
Probably, yeah.
Because you look at the insulation around it, it doesn't look like there was easy access to change that. So there's a 1-inch filter that's been in there for 25 years. Oh, Doug, I see high static. I actually didn't test. This system was barely running, and it was going to get removed, and we were going to do new ductwork, so it didn't really matter. I only test things if I think they're going to stay. Here's probably why the furnace failed. So there's the flue going out.
That's fun.
Built-in nest. And that's the stuff you find as you do it. Here's another top plate picture. Notice how black that insulation is. That was a lot of dirt getting filtered. And then this will be a little bit tricky to see, but if you remember from the back of the house where the chimney goes through the soffit, so we're just on the other side. This is the front of the house. And we want to seal the top plates really, really well. And so spray foam contractor opted to put ventilation baffles in these little holes here in the soffit, and then he foamed up against them. And then there's also ventilation baffles running up. So there's still attic ventilation happening here, but there's no air that can get through here or up to the top plate. So we hadn't used exactly that method before, so that was a little figured out as you go. And here's what the upper attic looked like sealed. So right here, this is a top plate that we put a little bit of closed cell across the top. Note that it's like a 1/2 inch thick. It's just enough to do the job. And then you can kind of see back here where the gable wall got sealed. So we did the top plate and a little bit up the gable wall to make sure that that got sealed. And this is actually post duct install, this exact photo. So there's one of the ducts going through. And then this was an ironic thing because we pulled the insulation out. What was it?
It was November.
November?
It was just before the cold snap hit. Yeah,
that's right. Because so I froze all the pipes in my house because I wasn't ready for it yet. I had to replace all the plumbing in my house, and I'd replaced them, but I hadn't got anything insulated, so it all froze. Anyway, for the first time ever, you got ice dams on your house.
Yeah,
which I thought was kind of funny in that picture. So there's no insulation in the attic. In fact, here's what it looked like in infrared. So look at all that heat just screaming through the ceiling because there's no insulation at all in the attic. You can see there's those recessed lights there as well. The curse was Peter called me one day and he's like, so when can we start the installation project? And I called the installation contractor. He's like, how about tomorrow? Great. And we did that. And then it was a month before the HVAC guy could get there. So your propane meter moved kind of fast for a month there. But you thought you'd have more to use than you ended up having to use.
It lasted until as long as it needed to. So
it did. We made it. You didn't have to buy more. So that's good.
That's right.
So here's the old system gone. And here's the new system in the middle of install. So we like using Bryant and Carrier equipment. You'll see me talking about it a lot. So this is the VNA 8. So it's the 18 or 20 SEER unit, as opposed to the very top of the line, which is another $3,000-ish, something like that. And then one thing that I didn't love about this install, but the poor guy was rushed, and how long was the HVAC tech there? It was like 8 days, something like that.
Yeah, probably. Well, probably even more, because they thought they would have it done in a week, and I think it dragged well into the second one.
Yeah. It was running a new duct system can be a pain in the tuchus, and it really was a one-man crew is what it worked out to be too. So anyway, I was hoping that this would be what we call badass HVAC, where this filter would be horizontal in the drop, but it just didn't work out that way. But we'll look at what the numbers are in a little bit. So that was getting put in, and then we needed to run ductwork upstairs, and Peter really didn't want to put the ductwork through his office.
That's correct.
I gave you a shove a number of times on that. You're like, nope, won't go. It's not going to happen. So we actually ended up punching out the basement, up through the garage, into the attic above the garage, back into the house through the second floor closet and up. So that was a pretty wild way to get it done. And then this is the trunk on the inside. So you can see this is the heat pump unit here. And here it is coming around and up. Important notes, if you can see that little nub right there, that's the damper control, so that Peter can put more or less airflow upstairs. So oddly enough, we're overheating your second floor now, right?
Not overheating, no. Before the temperature upstairs was pretty much uncontrolled in the winter, which makes it nice for sleeping. It's nice and cool up there. But in the summer, it was miserable. And if you turned on the AC and it worked, it was fine. But it only worked together with the downstairs AC, because else the upstairs one just wouldn't cover it. And I can only speak for the winter, because we only installed it in December, really, November, December. So right now, the upstairs to downstairs is within 2 degrees of each other. So too warm, only relatively speaking, that I would like it cooler for sleeping. That's it.
Well, you can choke that down a little bit more. I keep giving you a hard time for that. But I think in the summer you'll like me, because you can probably run the second floor a couple degrees cooler than the first.
That's right.
So we'll find out soon enough. By the way, this house was done without a duct design. So we don't always do that, but that was how this one worked out. So here's the outdoor unit, and I thought this picture was kind of fun because you can see it. It is totally ready for defrost mode. Look at that thing. It is all iced up. But note this over here. This is the fresh air intake. So this is an important part of badass HVAC. This particular unit, because it has a fair amount of return static and the fresh air duct was dumped right at the return plenum, this thing sucked hard. So on high fan, he's getting almost 70 CFM of fresh air, and usually we find between 30 and 40 is what we get. So that probably actually is really close to 62.2 for this house, which is actually 62.2 is the fresh air calculation in standard. And then you guys know me, I'm always looking for numbers. So one of the nice things about this particular system is it takes static pressures. So I needed 2 pictures here to show you that first it was in 5th stage. It's a 5-stage unit, so that's running flat out. Well, the airflow hadn't kicked up here for whatever reason. It's saying 400, but it was at 0.28 static. And I've got other pictures that match up to this. So that's what the unit was saying. And then I checked it against actual measurement. So the system was saying 0.28, and my manometer was saying 0.223. Nice brand on that manometer, by the way.
Yeah, that's a good one.
It's a really good one right there. So I mentioned that the filter didn't get put in quite the way that I was hoping for. But here's the exact number, so 0.17, 0.09. So it works out to 0.09 inches of water column across the filter. And these are rated to normally do 0.1, and really almost nobody actually gets that. If you measure, you're probably going to find 0.2, 0.3 across them. So we were still okay because it's a decent sized filter.
So Nate, for those that might be wondering, why would you rather have the filter horizontal if you had the option to move it?
Good question. So if you have it horizontal, the air is going to hit that filter pretty much equally as it falls. Where this, if you think about the air, like air moves like fluids. It moves like water at the pressures that we run it at. So it's going to follow this bottom curve here, and it's going to overwork the filter on the bottom side, and probably hardly any air is going to hit on the top side. It just ends up not working quite as well. It doesn't use the filter as evenly as it would if it was horizontal.
Cool.
But again,
now you tell me.
Yeah.
Well, it's not the end of the world either way, but it wasn't quite best practice. But I wanted to show warts and all. So here is the system running on second stage. So this is as low as it would let me run it at that time. And we were getting 0.07 static there. And at 0.07, we were getting almost 20 CFM of airflow outside. And by the way, shout out, this is Lucas Coons' hand here, who's another client, turned into a good friend. And then Peter, this ought to look familiar.
Yeah.
So we get the HVAC in, and he's like, Nate, this thing's really noisy, especially in my office. I'm like, oh, stink. So let's go see what's going on. And this one duct goes, this is his office right above here where he's sitting right now. And this was the only duct that came off right above the unit. So the vibration and the airflow noise was very strong coming through this duct right here. And it was pretty bad. Like, it was very distracting in his office when the thing was running on high, which happens a lot in the winter. So thankfully I had some 6-inch flex kicking around. So I took out this piece and put in a piece of flex. And that helped quite a bit, right?
Yeah, it's made quite a bit of a difference.
Just put a muffler on it.
Could do that.
Yeah. Well, that's essentially what you did. That's pretty cool.
Yeah. It's a little bit of flex can be useful for this. I've done that a couple of times. Not real often, but a couple times. And then kind of one of the last things in the HVAC side here. So this is the energy guide on the old propane water heater. And what was this assumed at? This is assumed at like 85 cents a gallon. So we're more like double that at this point. So that's a fairly expensive water heater to run through the year. And this is an energy guide off of the type of water heater you're going to put in, Peter. So you've got it sitting in the basement.
And that's the heat pump water heater, right?
Heat pump water heater, yep. This is the Rheem brand one, which right now has basically the best numbers on the market. Plus, they track their own energy usage, and they also have really good onboard diagnostics. So it's the nicest unit for the moment. Ask me in 6 months, my mind will change.
And they're a little quieter too, if I'm not mistaken, right? I know that's a complaint that a lot of people get from those.
They're almost silent. That one, where I had a GE in my old house, and that one wasn't noisy, but it was like a window fan running on high, something like that. But it's a little more vibrating than a window fan. Where those Rheems, you can barely tell when they're running.
That's cool.
They've gotten a lot better. John Semmelhack of Think Little did a nice little video where he put one right center mass in a house, and it was running, and he walked into the room, and until he stopped walking, you couldn't hear it.
Wow.
And even then, you could barely hear it. So center mass in the house, and it was still working fine. Cool. So next phase is air sealing and insulation. We're done with the HVAC for the moment. Let's see, Joe Madash, what is the recovery time on a heat pump domestic hot water? So it depends, Joe. The heat pumps themselves are pretty slow. So I watched on our old house My wife took a bath, completely drained a tank. And she likes lobster baths. I don't even want to put my hand in the water. She climbs in. And it took 4 hours for that tank to recharge from zero. Now, if you put them in hybrid mode and you get the resistance working as well, they're very similar in speed to a gas tank. Let's see, Andy Kosick did damper and controls on that. Yes, Andy, you're right. I didn't touch on that. So we do have a damper on the fresh air inlet. It closes below 20 and above 80. It's a totally separate unit. It's a little Ranco thing because the carrier equipment will only talk to a carrier branded HRV or ERV. It won't talk to anything else fresh air. So that's open almost all the time, except for when it's very cold or very hot. Hopefully that helps. Let's see, Mark Rich, what about filters that are at a slant, train, etc.? Mark, that's a good question, and I don't really have a great answer for you because I'm not an expert on airflow. I know kind of the basics, but I know those can help because air bears do that. It's a media filter that gets put at about a 45-degree angle so that you can put it in a very narrow, like an 8 or 10-inch wide return drop. So it probably would hit the filter more evenly on one of those. Let's see, Eric Kaiser, why is the intake so close to the LP regulator vents? Good question, Eric. That is not going to be there much longer. So that was just a compromise until the propane tank is gone. The only thing, well, did you get the electric stove in yet, Peter?
Oh, yeah. Yeah.
Okay.
Propane tank's the only thing left.
Yep. So that's the last thing. So it's a couple of months. It is what it is. There's always going to be some compromises in a project. Okay, so now we'll move to air sealing and insulation. So test in was 3,400, actually 3,300. It bounced a little bit. After the HVAC, we were actually up because some holes had been punched to run the ductwork out of the house and then back in. So here's one piece of the air sealing that got done. These are 10 mat covers. We don't always use these, but they happen to get used on this project. These are over the recessed lights. And they got spray foamed at first around them, but I also know that these things leak. Ask me how I know this. I had a painful experience with that. So the foam crew went in after this, and they're wonderful to work with, by the way. It's affordable foam. They're so nice to work with. They foam the rest of the top of these. So those are completely sealed, and these are made to turn a non-IC rated can into an IC rated can, but then they all have LEDs in them anyway. So shouldn't be an issue. And then if you remember earlier, I showed you that picture from the outside. It was of this assembly. It's not in this spot, but it's this assembly. So there's ventilation baffles here, and then there's a little ventilation baffle that's vertical there, and then they spray foamed against that. So now this is really well sealed, and that helped the numbers a fair amount. And up in the upper attic, so there's new duct system up there. This is the duct system that got foamed. And then we buried it in cellulose with only one exception. There's a little exception over here where it was so high that it wasn't easy to get cellulose on top. And in this case, I actually blew this attic. We had a 3-man crew, and if we were going to get the job done, I needed to climb in. So I got all messy on this one. It was back to the old days of being an installation contractor. And then if you remember, I showed this picture earlier with the ductwork through the garage. That got foamed, and you can't see it, but it's foamed in the attic up here as well, and where it goes into the house.
I hope you guys see how much space Nate wanted me to give up in my house.
Oh, I understand, but I wanted you to give that up, yes. We talked about like 5 different places before it was a Burton Sheet Metal did this work, and Kevin, the owner's a good friend of mine, he's like, why don't we just run it out here? I'm like, oh, and Peter's like, that's cool. Like, all right, we got to foam the heck out of that. Yep. So there it is. There's compromises that are made so that you can make a project work. So after we did the attics, I remember we were up to 4,300 before, and now we were down to 28. So we're getting there. The main target was 22 and the stretch target was 1500. So in the basement, we foamed all of the walls that were above grade. And this was a nice thing that came out of, we got a bid for it, but we weren't sure if it would fit budget, and the bids came back and it would make it. So we got to do that. Basement walls that stick up, they are horrible energy leaks. If you look at a house in infrared, they're really, really ugly. Kyle Palmer, now it would be really hard for any UV lights or humidifier with all the insulation of the ductwork. Oh, that ductwork was in the garage, not in the basement. It wasn't with the unit, and we're not big UV light fans anyway. But the house does have a humidifier. Then if you remember that picture earlier of the rim joists where they were leaky, here is Donnie spraying foam on one of the rim joists. So you can see actually how deep it is there, and he filled it. So there's like 4 inches of foam in that rim joist. And that helped a fair amount as well. And here's the unit after it was, the install was complete. So there's your humidifier, bypass humidifier. There's the media filter, the back of it, and then there's the unit. The propane water heater is still there and still is today, but it won't be for much longer. And then you can see the line on the wall where the spray foam was just where it was above ground. This is actually the garage here. We didn't necessarily have to do that, but we opted to do it. And then this is a good example of QC. So this is a drain line going up. We hit this later, but on the first run through, the holes going up to the floor didn't all get hit. And that's where doing some quality control afterwards really helps. Justin Dobson, why not automated zoning for the one badass HVAC system so we can control up versus down? We could do that. We've tried zoning a couple times, and with a 2-zone system, they tend to kind of fight each other, and we haven't had good luck. And we find that if you mix the house, so if you turn the fan speed up from like low to medium and you mix the house harder, that oftentimes does a better job than zoning anyway. Plus, with the shell work that we do, one of the issues that zoning is typically trying to solve is you get one room that has a much higher heating load than another one. So say it needs 20 BTUs per square foot to heat, where other rooms in the house need 10. You have to get double the airflow to that room. Where when we do these shell jobs, we typically will bring all the rooms closer to that 10. So if you mix the air in the house, zoning becomes much less of an issue. I haven't done it personally, but my business partner disconnected a couple of zoning systems because after a shell job, they weren't needed anymore. Now in 2.0, most houses are not going to get this level of retrofit, but there's a path to do it.
It kind of puts all the rooms in a house on an even playing field.
Yeah. Exactly.
Yeah, and I can really confirm that too. I mean, you really don't notice any temperature difference no matter where you are in the house. Maybe the basement's still a little bit on the cooler side, but that's about the extent of it.
Yep. Well, we could punch another supply down there. You'd probably be fine. It makes it good for exercising. So we were down from 3,400 to start to 2,800, and now we're to 2,600 on the basement. And I was starting to sweat at this point because I thought we would be further along. But here's where we get to the bump outs. So these are interesting when you're trying to spray outside. So you have to drop a bunch of plastic. And so that's Donnie doing that. And here it was just before Donnie was there. So we have to drop all of this soffit here and get in there. And you can either spray the floor and then seal this hole here, or you could potentially spray the floor underneath if there was a way to do that. So there's a couple different paths to do all of these things. So here's Donnie spraying. You can actually see there's foam flowing right then. And then, come on, honey. Here's what it looked like after it was sprayed. And note the little bits of orange here. I've got another thing. So the foam crew has come to call this Nate picking. So I go back and I'm looking for all the little things. So I didn't know for sure that it was going to leak, but I was there. I had the little orange foam gun in my hand, and I was on a ladder. So I just hit anything that I thought might leak so that I didn't have to come back and do it later. So it doesn't mean that any of those things would, but like you see a spot here that was where the foam was a little bit thin. So I don't want any really thin spots if we can avoid it.
That's where your smoke emitter really helps out. You can depressurize the house and stand out there. And if you see it get sucked in, that's a leak.
That's a leak. Your hand works decently for that when it's cold out too.
Sure.
But yeah, that can totally help. Because I love doing that with depressurization inside the house, looking for where the leaks are. We do a lot of smoking during the smoke testing, during the comfort consults. So now we're down from 3,400 to 2,800 to 2,600. Now we're to 2,200. So we've now at least hit the 2,200 target, but I knew that was a pretty easy target, or I thought it would be, so I wasn't satisfied by any means. And so then we did the front bump out, but the front bump out was problematic because some idiot didn't attach the bath fan line. So it may have gone through the wall, so it looked like it was vented outdoors. But Gary from Affordable Foam noticed that it wasn't connected. And he didn't have the parts to do it. So this actually stopped us that day, and they had to come back the next day and finish up. And here's Gary. He's stuffing this hole right up here to create something to spray against. So we just reused some of the fiberglass that was there and use it as a blocker. And then here it is with everything back up. And at this point, we were down to 1640. So we were pretty close. And how are we doing on time? Oh, we're past. Okay.
A little over, but that's okay.
We're nearing completion here. So tail end of the project. So we're down to 1640. And this is where I switch into optimization mode. So I've caught all the large leakage problems that I can, and then what I really need is a quiet house. So I come back the next day and come back with a blower door, and I start playing with things. And then I also take other measurements, like I was curious how loud was the outdoor unit, and this one's pretty quiet. The VNA 0, the top of the line one, when it gets cold out, they make a racket. But this one, have you noticed it ever being loud yet, Peter?
No, I mean you can tell when it's running higher, but only if you're standing next to the window that's
right there.
near the unit.
Yeah, well, they're not too bad. So another thing that we had here, though, was the duct system is still a touch slow, or it's touch small for this house. So nice thing you can do with this thermostat is you can have comfort airflow settings, or you can have efficiency airflow settings. And normally I set everything up to efficiency. But in this case, we ended up leaving it in comfort. But here's the wild thing. So 867 CFM, and that came to our 0.27 static. So you saw that earlier where it said 401 for some reason, but there's what you see normally. And then indoor airflow, when you put it on efficiency, runs all the way up to 1200. And note the big jump in static. So from 0.27 to 0.50. It's almost a doubling in static pressure, and this made the house noisy, so we left it here. But this is something you'll find when you start measuring static pressure. It was only 38% more flow, but it was twice that much extra pressure. So we were hitting the max of what that duct system wanted to flow. So you have to keep an eye on that. I'm glad we just had a setting in this case, Peter.
Yeah,
didn't
me
have
too.
to do anything exotic, just pushed a button. So here's the house post project, and something to pay attention to. If I can, where's my mouse? There we are. Whoop. Saying my internet connection's unstable. I love when that happens during a webinar. So in the ceiling, can you guys still hear me okay, by the way?
Yeah, you sound fine.
Good. So in the ceiling, these are the recessed lights. Before, this would have lit up very cold because they weren't air sealed, and you can see it's just the heat from the lights now. This was one of the things that I wonder what we didn't hit. So this is one of the cold spots. This is in between the two sections of the house. We hit everything underneath and we hit everything on top. So there's got to be some weird leak in the wall. I'm not quite sure what it is, but we didn't have access to it. So that's one of the minor failures. And you're going to have that. When you don't do the walls of a house, you're going to have some issues related to walls. In the kitchen, if you remember, this was really cold. So there's that picture there. Now this whole soffit is the right temperature. So what they ended up doing was we foamed the outside wall here, and then we stretched fabric across the top of this, and then we foamed over top of that fabric. So that was quite well air sealed. And then you can see this is a little bit chilly here from the stove. And there's a drop soffit in the bathroom looking just like what you'd like to see. And the cold is coming on the bath fan here. This is a crummy damper. They all have crummy dampers, except for the very top of the line ones. And I didn't show one of these pictures earlier, but this is top plates here. This is the top of the wall of the lower part of the house. And this was really blue before, and you can see that it's almost all the same color now. And then like this is a switch plate here, and you can see the slider leaking. And then also, so I was doing this infrared work trying to find any weaknesses that I could still tackle. And one of the only ones that I knew of that didn't make sense to hit hard with spray foam was around the trim of this basement window. So you can see where it's all lit up blue. So I caulked that thing, and I was hoping to get down to 1500. In fact, there was a steak dinner on the line. If I could get to 1500. I didn't quite make it. I got really close. I got to 1550, and I couldn't find anything else that I had access to seal anymore. But still, that was a huge drop from 3400 down to 1550. So like Peter said earlier, it's changed how the house feels. And then we also like to track things after the fact. So feedback loops are really, really important, and the faster the feedback loops, the better. So here's the usage from Peter's house over the last 2 months. I didn't compare this to the predictions yet, but Peter, how do you feel about 140 and 130 heating bills?
Well, I mean, that's basically very close to what I would have an average heating bill, an average propane bill throughout the year. So wow. Now we had a warm winter. It's a little bit unfair. Yeah. I would expect those numbers to be quite different if we have like a real cold spell. Mm-hmm. But still, this is 2 months. I mean, if we look at March, I think March it's down to like in the 500 kilowatt hours or something like that already. Yeah. So over a total year, the cost of my propane versus cost of electricity is no comparison.
That's kind of what I was thinking too, because you were using 1,100 gallons a year, if memory serves.
At minimum, yeah.
So that's like 1,600 to 2,000 a year, something like that. And a chunk of that is hot water. So let's say 400 of it is hot water. That still means 1,200, 1,600 a year. So $100 a month on average, and these are the 2 coldest months. So, and like you said, warm winter. So you might hit 200 on a really brutal month, but I don't think you're going to break 200.
Yeah.
So nice move. That's a nice thing coming from propane too. It actually does save money. And so the feedback loops are really important. There's another feedback loop too, and I just threw these slides in before we got started. So we like using Fubot air quality monitors. And in this case, the data is bad, which I'm going to show you in a minute because I wanted to be warts and all on this. But note that the temperature of his house, according to the Fubot, is running a little below 68, but it's also fairly consistent. It's not moving up and down too quickly. Are you setting back at night anymore?
Nope.
Nope. Okay.
It just runs. Yep.
So that's just what it's doing. If anyone here checks the chart of one of their houses, they'll probably find it a heck of a lot more spiky than this one. That's pretty even. The Fubot also tracks dew point, so we're doing pretty decent on that. But that'll be more interesting to watch in the summer. TVOC, this kind of surprises me that we're getting some big spikes. So Peter and I were talking about this before the call. There's probably something going on. So it's the dogs playing, it's exercise or whatever, something that's spiking things. But at least we are getting to where we've got some flat lines here. So there's some. But I do wonder what's going on there. And the curse of TVOC is you have to be Sherlock. You have to ask some questions and see what's going on to understand what's causing spikes. And then this is the dust, the PM 2.5. And the Foobot is prone, as actually are most of the inexpensive sensors, to getting dust stuck in the sensor. And then note how the level never goes lower than 35 here. So I asked Peter to blow it out, and he did. And you can see that it dropped from holding it 35 to 30. This should go quite a bit lower still. So we'll get that played with. But we like watching these sorts of things because you learn a lot. And so we made it through the process. Let's see, any other questions? Let's see here, Ryan Puckett. Yeah, 3-ton, 18 SEER. We probably could have done a 2-ton VNA 0, but neither one would really be a bad choice. And then Jeffrey Howard, cooking time period of day. Yeah, I looked at the timing on those spikes, and they were all over the place. Some were at night, some were in the evening, a couple were in the morning. So
I can tell you it's not cooking.
That's true. We talked about doing a better vent on your stove, and you're like, I don't cook. So I'm like, okay, doesn't matter.
Nah, I mean, one of the thing is the Foobot sits on the floor, basically in the bedroom, and I have 2 dogs. There's a lot of dog hair and dust running around, and I don't know what else they're doing up there, but.
They're pretty different in size, so probably not that. Did you remove the whole house fan? Yes, that was a piece of it. So that thing said goodbye. Okay, so this is kind of the last slide. If anyone wants to keep the conversation going, if you're a homeowner, go to the Electrify Everything group, and for contractors, go to the HVAC 2.0 advanced discussion. So Peter, this is where I'm just curious for your feedback. So how did you feel about the project overall and what the result was?
Overall, I think the project went really well. The only hiccup we had, and that was the time lag between the installation of the HVAC system and the insulation part.
Yep.
But that's it. I mean, we got unlucky because that was the cold spot. That was probably the coldest time of this whole winter that we had. I think it didn't get that cold in February than it did in November.
Yeah, so we got those couple days.
Yeah, so that's really the only thing. I mean, everything else I think worked really well. I think the crew that came out was nice, easy to work with, and I think the results speak for themselves. I mean, they were certainly. Like I would come home over lunchtime and check in, see what's going on, which is always a good idea because there's a few things that let's not go this way, let's go over here instead. just little things, but I mean, I would expect that it's my house. I want to have it done my way. So,
so Nate, I've got a question for you. I'm thinking about this from like an HVAC contractor's point of view. If there were to get a project like this that required some shell work, because most of the times when an HVAC contractor goes in, they deal with the system and the duct work, but if there's anything for the shell, that's the insulator's job. Yeah. So what's a good way for an HVAC contractor to match up with a good insulator to see that all the way through? How do you make a good connection there?
Yeah, a couple of pointers. So one path you could go would be to call your local weatherization assistance program. So it'd be a little government agency that does that, and ask for one of their contractors because they're going to understand building science far more than most. But if you need spray foam, because most of those guys are not going to have a foam rig, you kind of have to build the relationship. And for that, I recommend sticking to smaller contractors. So 1 or 2 crews, preferably where the owner is still active on site. And you need to find somebody who's open and wants to learn. So Gary Smith of Affordable Foam, he is also an engineer by training. So he and Peter got along quite well. And I ended up being the butt of a couple of jokes through all of that, which is fine, totally fine. We all had fun. We always have fun. But Gary's mindset is to learn how to do things well and to continue to get better. So we work very well together. But he's the fourth fourth insulation contractor I've worked with, and I'm also on the fourth HVAC contractor that I've worked with. So you have to find somebody who really cares and wants to do the best job. It's doable, but you need to plan on, just like hiring employees, you're going to go through a couple people probably before you find the one that you want to work with.
Sure. Sure. Yeah. Thanks.
Yeah, I can certainly also agree with like the crew that was at my house was very professional and it worked really well. For anybody who has never worked with foam or whatnot, you'd be surprised how much overspray you have on little things of like even door handles and whatnot. So if you want to protect yourself against that, do more taping than you think you would or should.
There's always little things, that's for sure.
Yeah.
Preparation and spray foam is very important because if something isn't covered, it will get overspray on it. That's the wonder of foam. Eric Schilling is asking, I may have missed it, but how did you come up with the calculation for CFM to square foot ratio grading? I made that up. We made that up. But when you do enough projects, you start seeing patterns. And right in that 1-to-1 ratio, everything starts to work. And it's also much simpler to explain to a homeowner. Peter, would you prefer a volume calculation or here's what your number is to your square footage?
Yeah, the easier to understand, the better it is, I guess, right?
Yeah.
I mean, if you get too detailed and too nerdy, you probably lose people.
Yeah. Impressive coming from a nerd, fellow nerd.
It's true.
Well, BPI has a standard as well as when they start to recommend ventilation. So whenever you match the floor area with the blower door number, that's when they start recommending bringing some outdoor air in. So
yep.
It's been around for a little while.
Actually, that is exactly where it came from in my mind. Come to think of it, it was in being an insulation contractor in the utility rebate program here, which is the last business iteration. I kept noticing like what is it? Building airflow standard, BAS.
Oh yeah.
That consistently came out to be the square footage of the house within 100 or 200 square feet, and I was like, oh, that's kind of interesting. And then in watching the projects that we did, when we got them under 1-to-1, almost everything came to heel. It just started to work. So hopefully that helps.
Yeah.
BPI had a stop level. Yeah, don't stop, just ventilate. Yeah, good question. Good point, Joe Madash. Mike Porpora, how do you ask homeowners for their budgets? We have a very specific script for that. That's part of 2.0. And that can be challenging. And then you get a client like Peter who wouldn't give me a budget to do the whole thing.
Try selling me a car.
Somebody did. You got a pretty fast car sitting in your driveway. Okay. Any other questions? Sam, you got anything else?
I think that does it for me. If there's nothing else coming in the box, thanks to both of you guys, Peter and Nate, for coming in and taking some time this afternoon to talk through this project. I don't know where else you can go on and see a discussion after the fact of the contractor and the homeowner where everybody's happy with the end result. So yeah, this is awesome. And some great pointers too, just to see, I'm sure people can pick some stuff out and say, oh man, we could have done this for this project. So I'm sure it'll be helpful all the way around. And we'll get this edited up and posted to our YouTube channel as well. So if you go to YouTube and type in Retrotec Energy, we'll have this up there. So if you have a friend or colleague that you want to see this later, we'll have it up there for them to view.
Perfect. And Sam, thank you for hosting.
Right on. Yeah, anytime. Nate's been on here several times, and we've always had some good discussions. So I'm sure there'll be more in the future as well.
So we'll see if any other clients are as crazy as Peter. Thank you, Peter, for coming on. I really do appreciate it.
Yeah, that was fun. I hope everybody got something out of my input as well.
I did.
Yeah, for sure. For sure. Great. Well, we'll call it a wrap then. Thanks, everyone. Thanks for tuning in.
Guys, have a good one.
Thank you. Bye, everybody.